Okay, this lesson, we're going to start talking about chemical bonding. So we're going to look at the differences between ionic and covalent bonds. So by the end, you should be able to compare and contrast them, talk about how they're different and how they are similar. The way that you're going to do this is through, we used to do it through stations in class, but I've modified it so it's all on the Google Doc that is attached to Schoology. So you're just going to work your way through. There's a watch it section. There's a read it section where you'll read a little bit and answer some questions. An explore it section, organize it. I've cut these out here. And then you will have a little exit slip at the end that you will need to submit through Schoology. It'll be the Google form exit slip, okay? So let me scroll through. You'll do all those yourself. Okay, so now once you finish the stations, you should be able to kind of use what you've learned and write a few things about the differences between ionic and covalent bonding, okay? Here's what I've written. I know that an ionic bond is between a metal and a nonmetal. I know that electrons are transferred, and it creates ions. That's how it gets the name ionic bond. A covalent bond, it always has nonmetals, okay? And then our electrons are shared. So make sure you've copied this down into your notes. There's a few other things we need to write down on this chart as well, and these are just properties, characteristics about these two types of bonds. So our ionic bonds are a little bit different than our covalent bonds, and it mainly has to do with the structure that they form. Our ionic bonds are very strong, and because of that, they have a very high melting point. They form these kind of crystal-like solids. So if you think like table salt, okay, table salt, NaCl, okay, it looks kind of crystal-ish. They can conduct electricity when they're dissolved. So I feel like I need to add that in there. When dissolved, like so if I add it into water, okay. It's soluble, that means it can dissolve, all right? And then if I look at covalent, I almost see that they're the exact opposite. So they have a low melting point. These can be gases, liquids, and solids, whereas our ionic bonds are always just solids. They're not very good at conducting electricity, and they're usually not soluble in water. So if you think about oil isn't going to mix with water. During your stations, you should have been able to define the octet rule. So this is just the tendency of atoms to want that full outer shell, right? So they want to have that full 8 electrons in their outer shell. So remember we looked at Bohr models, right? And we can have many different shells. But as long as we have that outer shell is full, 2, 3, 4, 5, 6, 7, 8, this is satisfying our octet rule, okay? And then don't forget hydrogen and helium are different because they only need 2. Because if you think about hydrogen, hydrogen, right? It only has 1 electron, and that first energy level can only hold 2. So it really only needs 1 more to have that happy full shell, okay? So that first shell can be full with just 2. So let's look at our this chart here. We're going to talk about covalent bonds first, okay? Covalent bonds, remember, they share electrons. And so we're going to complete this chart because we're going to look at how we can show how they share drawing our Lewis dot structures. So if I look at hydrogen, right, I know hydrogen's atomic number is 1. Okay, so that means it has 1 proton, 1 electron. It's in group 1, that first column, so it has 1 valence electron. And remember, it only needs to fill that first shell. So it really only needs one electron to fill that outer shell. Okay. So what I want you to do is take a second, see if you can fill in chlorine and oxygen. Okay. Remember, you're looking at their atomic number to help you figure out their number of protons and electrons. And remember, our valence, we can kind of cheat. And remember, we numbered our columns across the top. So that'll help you figure out your valence electrons. So if you need to pause here to fill out this chart, go ahead and pause. So this is what your chart should look like now that we've completed it. We have our 17 protons, electrons for chlorine. Its valence electrons is 7 because it's in that group 17, that column, that seventh tall column. So it really only needs one electron to fill its shell. And then oxygen, because it only has 6, it needs 2. Okay, remember everybody wants 8. So we're gonna try to practice some showing our covalent bonds using our Lewis dot structures. So the first thing I'm gonna do, I know hydrogen has 1 electron, right? But I have 2 hydrogens. Okay, so if I write 2 of my hydrogens here, okay, and they each have 1 electron, I can actually show that they're sharing these 2 electrons by drawing a line like this. Okay, so remember we said hydrogen only needed 1 more in order to have that full shell. It just needs 2 total. So if they're actually sharing these 2, right, then they each have that full shell that they need. Okay, so I can show that by drawing this just a line like that. Okay, let's look at H2O. You're always going to want to have your single element in the center. So because oxygen is by itself, I want that in the center. And remember, we just said oxygen had 6 valence electrons. So I'm going to draw my 6. Remember, we treat it kind of like there's that invisible box. Okay, so there's my 6. And then I know hydrogen has 1 each, and there's 2 hydrogens. Do you see some spots that seem empty, that maybe we could put a hydrogen? I think I can change colors and maybe we can see it. So if I say, okay, here's hydrogen, he can kind of fit in right there, kind of like a puzzle piece, right? Now, oxygen can share that electron and hydrogen can share that blue one. And if I put my other hydrogen down here, there's hydrogen's electron. Now, if I look closely, right, oxygen has these, right? And then my hydrogen, they're sharing these, okay? So now everybody has the 8 that they want, and hydrogen has the 2 that it wants. So the way that we can write this, if you want to write it like this, that's okay. If you want to write it like this, that's okay too. You just have to make sure you show your other electrons as well. So I can use a line where they're sharing, but I still need to draw my other single dots. All right, let's look at my chlorine here. So chlorine, we said, has 7 valence electrons. Okay, sorry, my dots aren't looking very pretty. Here's my other chlorine. He also has 7. Okay, so here I can see how they're kind of, they can actually share these 2, right? So this chlorine can have those 8, and this chlorine can have these. Okay, so they're kind of sharing those 2 in the middle. So remember, I can use a line to show how they're sharing, and then I can just fill in my other electrons. And we already did hydrogen. I'm sorry, that's there twice. All right, so I want you to try to do these. So pause where you're at, okay, and then I'll write these out really quick. So go ahead and pause. Try these just on your own paper. If you're at home, you can do it on your own paper. So make sure you pause because I'm gonna work these out. So my sulfur's in the middle. Sulfur has 6 valence electrons. Hydrogen just has 1. So I can leave it like that, or I can draw it like that. Fluorine has 7 electrons. They each have 7. They're going to share that one in the middle. Okay, carbon, remember, has 4. And then hydrogen each has 1. So you can leave it like that, showing that they're sharing, or you can write it with the lines, right? Because lines mean the same thing. I'm sharing 2 electrons. So there's 2 different ways you can write each one, okay? All right, lastly, let's talk about ionic bonds, all right? So for our ionic bonds, remember, these are transferring electrons. Okay, so they're going to transfer electrons, not share. So we're going to do the same thing. Let's fill in our number of protons, electrons, and valence electrons, and then we'll do this part together. Okay, so wait for this. We'll do this together, but go ahead and take just a second to fill out your chart. So just pause here. All right, so because we're transferring electrons, okay, we're going to do kind of the same thing. How many electrons do we need to fill our outer shell? Okay, but because they're going to transfer, we want to think about it in the terms of them moving. So it's not just that they need to share some, it's that they might actually need to take some away, or they might need to give some away, okay? So sodium has 1 outside electron. But remember, underneath that energy level is a full shell, a full energy level. It just has 1 extra one on the outside. So is it going to be easier to lose 1 or to take 7 from somebody? Okay, it's going to be a lot easier to lose 1 electron. Then they have that full outer shell because that 1 single electron is now gone. Okay, for chlorine, it already has 7, so it's going to be a lot easier for it just to take 1 or gain 1 in order to get 8. Okay, magnesium only has 2, so is it going to be easier to lose 2 or gain 6? All right, we're going to lose 2. And then fluorine's just like our chlorine, we're going to gain 1. Okay, so remember, right, if we're losing or gaining, we're going to actually be showing that in our drawings. So let's look at NaCl, okay? So Na has 1 electron, and here I'll do it in another color. My chlorine, we said, has 7 valence electrons. And remember, we said we want our sodium to actually lose an electron, and then our chlorine, we said we want it to gain an electron. So that's what we're going to show. We're going to show sodium actually giving its electron over there to chlorine. Okay, so that's all I'm going to do. I'm just going to show that arrow, how it's moving. Okay, but remember, when we have ionic bonds, we form ions. So we need to remember that our electrons are negatively charged and our protons are positively charged, okay? So if I have sodium here, it's neutral. That means it has the same number of electrons and protons, so everything's even. If I lose an electron, now that means I have more protons, right? And I just have 1 extra, proton because I've only lost one electron. So that means I have a +1 charge. My chlorine, though, has gained one negative electron. So that means now it has one extra negative. So we're going to write a -1. Okay, let's look at magnesium chloride. So I have my 2 valence electrons for magnesium, and then chlorine has 7, right? But I have 2 chlorines. That's what this 2 means. It means I have 2 of them. So I'm just going to write them next to the magnesium, okay? And so each of these chlorines needs 1 electron. So they're actually going to take it 1 each from magnesium, okay? Because remember, we said magnesium wants to lose those 2 electrons. So if each chlorine has gained a negative electron, they have a 1- charge. But my magnesium, it's lost 2 negative electrons. So remember, this is like now it has 2 extra positives. So my magnesium is going to be a 2+. Okay, the charges is usually what's the most confusing. Okay, so we already did that. Let me do one more. Sodium. Fluorine, we said, has 7. Okay, we're just drawing our valence electrons, remember? And then sodium's going to want to give up that electron to fluorine. Okay, so now fluorine has 8. When it gets that extra, it has a 1- charge. Sodium lost that electron, so it has a 1+ charge. Okay. So pause here, try to draw these on your own paper, okay? And then you can play it and see me working through them. So I'm just drawing the valence. Lithium's going to give 1 away. That means it's a 1-. Bromine's 1+. Calcium has 2. Each of my fluorines are going to have 7. Okay, so it's going to take 1 from that and 1 from that. That means that each of my fluorines has a 1-, and then my calcium has a 2+ because it lost 2 negatives. Potassium's going to give 1 away. 1+ and 1-. Okay, so check your answers on your paper. I think there's one more question on your notes that's kind of talking about how do these ionic bonds stay together. So if they're sharing these electrons, or they're transferring their electrons, what's keeping them together, right? If I'm giving the electron away, what's keeping me from just wandering, floating away somewhere else? So the way that this happens, the way that they stay together is because of the attraction between those positive and negative charges. So remember, we said our sodium, when it transferred that electron, it had a 1+, and chlorine has a 1-, right? And this is just like a magnet. There's an attraction between these molecules because of that positive and negative charge. So we can see over here, they actually kind of form this like alternating structure. So I have like, here's my chlorines, and then my little sodiums are kind of wedged in between here, right? It's kind of like an alternating structure. Okay, so that's how they're attracted together. They're just, they stick just like magnets do. You have some independent practice on the bottom of your page. This is going to be your exit slip. Okay, so once you get done doing this, instead of a Google form, I'm sorry, I changed my mind. You're just going to upload a picture of your independent practice. Okay, so I can see how you did. Okay, so I think there's a few of them down at the bottom. Remember, first you're going to do is figure out if they're ionic or covalent. If it has a metal, right, it's going to be ionic. If they're all nonmetals, it's covalent. Then you're going to draw your Lewis dot diagram.